Alright folks, I'm homesick today, so here's the lesson for 5.6 day 2. So now we have 4 ways that we can find the zeros or the roots of a function. Those 4 ways are to solve by factoring. That's probably the easiest way if the equation factors. The other way is to take the square root of both sides, which if you're missing an x term, that is the best way to do that, as well as if it's in vertex form, that's another good opportunity to use square root both sides. And then if it doesn't factor, then we can use the quadratic formula or completing the square. I think the quadratic formula is probably more popular for that. So let's look at some problems. This first one here, and by the way, my handwriting is going to be horrible on this because I'm just doing this on the computer, but I'll do my best. So this first one, we have an equation, quadratic equation. Looks like it's going to factor pretty easy, so I'm going to try and factor this. And wow, is that crusty? We have x and x and 2 factors of 10 that have a sum of 7 that are going to give me my middle term of 7x would be 5 and 2. So this one factors. They're both plus plus. So now we can use the zero products property, because when we're finding the zeros, remember we're setting this equal to 0. And so what makes this factor x plus 5 0 is going to be -5. And what makes the x plus 2 factor 0 is -2. So that's really the best way, is if it factors easy, go ahead and factor and solve it. This next one too, when we're missing a c term, a constant, this one is also going to factor, and it's kind of like an undistributed factor where we can factor out the GCF, and in this case it's just x. So we have the greatest common factor of h of x is x. So we factor that out and we're left with 3x minus 5. Okay, so there it is in factored form. This actually kind of confuses people when this x is a factor, but that x means that if 0 is in place of x, this equation is going to be true. So 0 is one of the roots. And the other one here, when 3x minus 5, that's Arlo. 3x minus 5 is going to be 0 when x is the opposite of 5, -5, which is positive 5 over 3, so 5/3. So those two factored, so that's the easiest way to solve those is by factoring. On the next page, excuse me, we have a function that is missing an x term. So I told you earlier, if it's missing an x term, we can get x squared by itself, and we will be able to square root both sides to get the values for x. And I was just checking your quizzes, and a lot of people are forgetting the plus and minus. So x squared is going to equal 19/2 in this case once you solve for x squared. And so once you get x squared by itself, now we can take the square root of both sides of the equation. So I took the square root there, and don't forget that after you do that, when you're solving an equation, you have to consider plus and minus. And in this case, square root of 19 over 2, that's going to be the same as, after you rationalize the denominator, the square root of 19, wow, this is really hard to write like this. Square root of 19 over square root of 2. But we can't have a square root in our denominator, so we got to do the old rationalizing the denominator. So multiply by root 2 over root 2. And we end up with square root of 38. Square root of 38 over 2. And what did I tell you not to forget? the plus or the minus. So x is equal to plus or minus the square root of 38 all over 2. If you solve that with the quadratic formula, you should get the same result, but it's just a lot easier to use square root both sides. Number 4, this one does not appear to factor all that easy, if at all. So I'm going to use the quadratic formula. This is a DNFUQF. Does not factor, use quadratic formula. But before you do that, you have to get the 3 over to the other side. So that's going to be negative 5x squared plus 7x plus 3. So the c is a positive. Because before you use quadratic formula, you have to set it equal to 0. And it has to be in standard form. Okay, so there we'd use quadratic formula. My a is going to be negative 5. My b is going to be 7. And my c is going to be 3. So I'm going to check that one for you. I'm not going to write it all out because it takes forever to write like this. But I'm going to do that one. I'll check it for you, and I'll put the answer down here in just a second. That was 1 sec. So here is the answer would be 7 plus or minus the square root of 109, and that should all be over 10. Whether you put it all over 10 or you have it split up apart, both of them are the same. And some of you might be asking about when you solve this, the denominator ended up being a negative, and then this part ended up being a negative. And so if that's the case, and we have a negative over a negative there, the plus or minus is going to cover both the positive and the negative case for this part anyways. So instead of writing a negative over a negative, we just would write that as a positive 7 and a positive 10 like that. Okay, so if it doesn't factor, use the quadratic formula. Another one here, 4x squared plus 1 equals 4x. This one you'd have to take this 4x and move it over here, set it equal to 0, and then see if it factors. If it factors, great. If it doesn't, use quadratic formula. And so I will take a look at that one here so we're not spending too much time, and see if it factors, or use a quadratic formula, and I'll tell you what it is. So just a minute. Alright, I'm back, and I determined that this one does factor. So when I got it all set equal to 0, I noticed that it was a perfect square. So the first two terms are going to be 2x and 2x. That's the square root of 4x squared. And then the last two terms, the square root of 1. And the middle term is minus, so they're both going to be minus. And if I FOIL that back out, I'll get what I started with. So this one has only one root, and that root is positive 1/2. Okay? So what that means, if it only has one root, is that that root is going to be where the vertex is, because that is going to be your axis of symmetry, and it's only going to cross in one spot. This last one I threw in here extra because it is in vertex form, and when you're finding roots in vertex form, it's probably easiest to use the square root both sides, because it's already kind of set up like complete the square. So for this one, you want to add the 15 over to the other side, because we're going to find the zeros, so we're going to put 0 in for y. So we add the 15 over, and then we move the 3 over by dividing by 3. So basically, on this side over here, we have a positive 15 divided by a 3, which ends up being 5. So we have 5 equals x minus 4, the quantity squared. Okay, so how do I get rid of a squared? Square root. So I take both sides, I take the square root of both sides. We've done this before, don't forget the plus or the minus. So we have plus and minus right there. And so I deposit there, so where was I? We had plus or minus square root of 5 right? So a lot of people forget that plus or minus, so don't forget that. And then once this is square root on the right side, and you square root the x minus 4 squared, that x minus 4 squared part goes away. So now we just have x minus 4 over here. And then on the left side, we should have plus or minus the square root of 5. So when you write that, you solve it for x. Okay, so we just have to move the 4 over by adding 4 to both sides. Gosh, really hard to write with it. So when I add 4 to both sides, I write it right out in front of the plus or minus square root of 5 stuff. So my final answer should be 4 plus or minus the square root of 5. You could also solve that by getting it in standard form and then from there setting it equal to 0 and using quadratic formula, but it's a heck of a lot easier when it's already written in that vertex form, that complete the square method. It's already written like that, so let's just solve it using square roots. So your assignment for today is a mixed worksheet. You should have lots of work time, so use your time productively, and I will see you tomorrow.